So after we've graphed a system of constraints, the next thing we do is find the vertices of the graph. So what we want to remember is that a vertex is any spot where our two lines intersect, but is also touching the shaded region. So if we look at our graph, I can see here we have our two lines intersecting, here are two other lines intersecting, but because that's not touching our shaded triangle up there, those are not vertices. If we look, there's a vertex there, then we've got this one over here. I'll go ahead and label A, B, and C. Now remember, if you have a vertex that's on an x or y axis, you can go ahead and just look at the point. We don't have to solve the system. So we know vertex A is 0 for the x, and it goes up to a 7. So we have the point 0, 7. Vertex B is not on an axis. We're going to have to find that, but we can go ahead and write down what vertex C is. 0 for the x and up 4 for the y, so 0, 4. And now we have to look at this vertex B. So what we do is we figure out, well, which two lines gave us this point right here. It's the green line and the black line. So I'm going to take those two equations and put them together. We have 2x plus y. Now we're going to be solving a system of equations. When we do that, we can just go ahead and use an equal sign because we want to know the point where these two cross. So 2x plus y equals 7, and then x plus 4y equals 16. And now let's solve for x and y. I think this looks like it's set up pretty nicely for elimination. You could use either one. I'll go ahead and multiply the bottom by 2 so we can eliminate the x's. And we have 2x plus y equals 7, and now we have a negative 2x minus 8y equals a negative 32. We add these two equations together, the x's eliminate. Y plus a negative 8y is negative 7y equals 7 plus negative 32 is a negative 25. Divide both sides by negative 7, and we have y is equal to 25 sevenths. It's a fraction that can't be reduced, and maybe we would say, I don't know if I did that right. We can double check and look on the graph. If we look up at the graph for this point that we're looking at, 25 sevenths is, 3 and 4 sevenths. Does our y value look like, if we go over to the y-axis, does it look like it's about a 3 and 4 sevenths? And I would say that looks pretty good. That looks right about where that is. So now that we found the y, we're going to go ahead and plug that in to get the x. So x plus 4 times 25 sevenths equals 16. I'm going to go ahead and just erase a little bit so I have more space. So x plus, we can make the 4 a fraction, multiply straight across. We have 100 over 7 equals 16. Then we want to subtract 100 sevenths from both sides. So 16 minus 100 sevenths. And we can multiply the 16 by 7 over 7 so that we're working with a common denominator to subtract the fraction. So really we have 112 over 7 minus 100 over 7. I'm going to write up here. The denominator stays the same, so we have a 7, and the numerator 100 minus 12 is a 12. So there's our y. So we can come over here and say vertex B is the point. The x was, we just found the x. The x is the 12 sevenths, and the y was the 25 sevenths. And again, checking that on the graph, 12 sevenths is 1 and 5 sevenths. And if we look at the graph for the x, kind of take the point and go down to the x-axis, is that around 1 and 5 sevenths? And I would say that that looks pretty good. So solving a system of equations for any vertex that's not on the x or y axis.